Our first example is example 1. A dam has the shape of the trapezoid shown in figure 2. The height is 20 meters and the width is 50 meters at the top and 30 meters at the bottom. Find the force on the dam due to hydrostatic pressure if the water level is 4 meters from the top of the dam. So what we want to do is we want to think about force equals pressure times area from above. That is, we want to think about the force of the ith strip, which would be the pressure of the ith strip times the area of the ith strip. So we want to take our trapezoid and starting at 0, measuring down to 16, we want to look at strips where we can find an area and a pressure. Then we'll sum up those strips using an integral. One thing that we have to notice is that this makes a triangle on either side, so the area is changing as we decrease in depth. We can take the x-axis, if we want to do this all in terms of x, we can take x to be the depth of the current strip, which means we would have a delta x as the width of the current strip. So we also need to know the base of this rectangle in terms of x. So looking at the right triangle that we're dealing with here, we know that if we were to extend these lines up to the top, then we would have 30 meters here and then 10 meters on either side, which gives us a 30 by 20 triangle, and a similar triangle of, we could call this A by, we need the height of this triangle, and the height of this triangle would be 16 minus x, because remember we want to get the A in terms of x. So using similar triangles, we have 10 over 20 equals A over 16 minus x. Or, clearing these fractions, we have 1/2 times 16 minus x equals A. So back to our area. Our area of the ith strip is going to be the base times the height. The base of this is going to be 30 plus 2a. The height is going to be delta x. We're almost there because we want a in terms of x. Substituting back in, we have 30 plus 2 times 1/2 times 16 minus x times delta x. Note here the 2 and the 1/2 can cancel, and combining like terms, that gives us 30 plus 16 is 46 minus x times delta x. Okay, so we found the area of this rectangular strip here. Now we need the pressure of the rectangular strip. Scrolling back up, we know that the pressure is equal to what? Well, it's going to be the density of the water times the distance underwater times the acceleration due to gravity. So, right there. So our pressure of the ice strip is approximately equal to density of the water. Since we're dealing with standard units, we have 1,000 for the density of water, times acceleration due to gravity, that's not changing, that's 9.8, times the distance under water, we called that our x sub I. That's x sub I. So the force of the water on that ice strip is going to be the pressure times the area, which is 1,000 times 9.8 times x sub I times 46 minus x sub I times delta x. Looking back at our picture, we want x to range from 0 all the way to 16. So to find the total force, we are just going to integrate from 0 to 16, which will add up all of our tiny strips. We don't need our i's anymore. And our delta x becomes a dx. Notice we can factor out some constants here, giving us 980 times the integral from 0 to 16 of 46x minus x squared dx, which is not a very hard integral considering some of the stuff we've had to do lately. 46 over 2 x squared minus 1/3 x cubed from 0 to 16, and that works out to approximately 4.43 times 10 to the 7, and the units are force, so we're dealing with newtons here.